Sometime in the next decade, a rocket will land on Mars carrying human beings for the first time in history. And the people on board will know when they step out onto the red surface that they are never fully coming home. Not because they cannot return, but because Mars will have changed them, because they will have crossed a threshold that no human being has ever crossed before, and because the world waiting for them back on Earth will feel in some irreversible way smaller than it did before they left. This is what life on the first human Mars colony will actually look like, not the version in movies, the real version, the one that is harder, stranger, and in some ways more remarkable than anything fiction has imagined. The journey alone will take between 6 and 9 months depending on the alignment of Earth and Mars in their orbits. There is no shortcut, no faster route. 6 to 9 months in a spacecraft roughly the size of a large apartment shared with a crew of perhaps 6 to 12 people. In that confined space with no possibility of rescue or resupply, with a communication delay to Earth that grows from minutes to over 20 minutes each way, the crew will be genuinely alone in a way that no human expedition in history has ever been. Astronauts on the International Space Station are never more than a few hours from emergency return. Apollo astronauts could reach Earth in days. Mars colonists will be on their own, separated by hundreds of millions of kilometers for years. Everything that breaks, they will fix. Everything that fails, they will solve. Every medical emergency will be handled on site with whatever equipment and knowledge they carried. There will be no evacuation. The surface of Mars is not hostile in the way most people imagine. It is not dramatic. It is quiet and cold and empty in a way that is harder to prepare for than any specific danger. The average surface temperature is minus 60 degrees Celsius. At the poles in winter it drops to minus 125. The atmosphere is 95% carbon dioxide and less than 1% of the pressure of Earth's atmosphere, which means that without a pressure suit, the colonists would lose consciousness in seconds and die within minutes. The Sun on Mars provides about 43% of the light it provides on Earth. Days are 24 hours and 37 minutes long, so close to Earth's day that the human circadian rhythm adapts relatively easily, which is one of the few physiological advantages Mars offers. But radiation is not one of those advantages. Without Earth's magnetic field and thick atmosphere to protect them, Mars colonists will receive radiation doses far exceeding what astronauts on the ISS receive. The habitat will need significant shielding, likely achieved by burying structures under meters of Martian soil, using the planet itself as protection against its own hostility. The first colony will not look like anything in science fiction. No gleaming domes, no terraformed landscapes, no dramatic vistas through large windows. The first habitat will almost certainly be underground, carved from lava tubes or buried beneath meters of regolith. It will be small, functional. Every cubic meter of pressurized space will represent an engineering achievement that could not be taken for granted. The colonists will spend the vast majority of their time indoors. Excursions to the surface will be planned meticulously, limited in duration and governed by strict safety protocols. Every EVA, every excursion outside the habitat will be a calculated risk. Inside, the space will be designed for maximum efficiency and minimum psychological strain. Lighting designed to simulate Earth's natural light cycle. Plants grown hydroponically, serving both nutritional and psychological functions. Carefully managed sound environments. Every design decision aimed at preserving the mental health of people living in extreme confinement on another planet. Food on Mars will be nothing like food on Earth. The colony will not be able to rely on resupply missions for something as heavy and perishable as food. The logistics are simply too costly. From very early in the colony's life, the colonists will need to grow the majority of their own food. This means intensive hydroponic and aeroponic farming, plants grown without soil, using water and nutrient solutions under artificial lighting powered by nuclear reactors or solar arrays. The caloric density of what can be grown in the space available will determine how many people the colony can sustain. Early diets will be functional but monotonous. The psychological impact of losing the variety, taste, and cultural significance of food will be one of the more underestimated challenges colonists face. Food is not just fuel. It is comfort, ritual, memory, and connection to home. Losing its variety will be a form of slow grief that researchers who study long-duration missions take seriously. Water on Mars is not absent. It exists as ice, locked in the polar caps and in permafrost beneath the surface. But extracting it, purifying it, and maintaining the infrastructure to deliver it reliably will require constant engineering effort. The colony will operate on a closed-loop water system, every drop of moisture recovered, recycled, and reused. Shower water, cooking water, even moisture from breath captured and returned to the cycle. Nothing wasted, nothing lost. Oxygen will be manufactured through a process called electrolysis, splitting water molecules into hydrogen and oxygen using electricity. The MOXIE experiment on NASA's Perseverance rover has already demonstrated that oxygen can also be extracted from Mars's carbon dioxide atmosphere. Both methods will likely be used in parallel because redundancy on Mars is not a luxury, it is survival. The psychological challenges of Mars colonization may prove more difficult than the physical ones. The communication delay alone will transform the nature of human relationships in ways that are hard to fully anticipate. When a conversation with family on Earth involves a 20-minute wait between sending and receiving each message, the texture of connection changes fundamentally. Real-time conversation becomes impossible. Everything becomes letters, thoughtful, deliberate, delayed. Isolation, confinement, monotony, extreme risk, the constant awareness of vulnerability, these are the conditions that psychological research on long-duration missions has identified as the most significant threats to crew well-being, not dramatic disasters, the slow accumulation of stress, boredom, and longing. Research from Antarctic winter stations, the closest analog to Mars in terms of isolation and confinement, consistently shows that the psychological peak of a mission is not at the beginning or end, but in the middle where the novelty has worn off and the end feels impossibly far away. Psychologists call this the third quarter phenomenon. On a Mars mission, that quarter could last months. The colonists will need psychological support systems built into their environment, meaningful work, clear purpose, autonomy over their schedules, rituals that provide structure and comfort, and design spaces where they can be alone when they need it. Despite all of this, despite the cold, the radiation, the monotony, the danger, the distance from everyone they love, there will be a morning, somewhere in the first weeks on Mars, when one of the colonists steps outside into a pressure suit and watches the sun rise over a red horizon. And the sky above them will be a pale butterscotch color unlike any sky ever seen from Earth. Two moons will be visible, Phobos and Deimos, small and close, racing across the sky faster than any moon on Earth. Dust devils will spiral in the distance. The ground beneath their boots will be ancient and rust-colored and completely, perfectly silent. And in that moment, they will be standing somewhere no human being in the entire history of our species has ever stood. Looking up at a sky that belongs to another world. Looking back in the direction of a small pale dot that is every person they have ever loved and every place they have ever known. And they will understand in a way that no description can fully prepare them for why we do this. Not for resources, not for escape, not even for survival, though survival may eventually depend on it. But because this is what humans are, curious, restless, reaching always for the next horizon no matter what it costs. We are going to Mars, the only real question is when. And what we find there about the planet and about ourselves will change everything.